Hello everybody. Today we're going to look at how do you solve triangles that are not right triangles. So we're going to look at the law of sines and then the law of cosines. Now I'm going to start with the law of sines. Law of sines says the following. It says if you've got a triangle whose angles are called C and A and B, and notice I'm using capital letters for the names of the angles, then we're going to call the sides opposite the angles by lowercase letters. So angle A, capital A, is across from side little a. In geometry, you would have called that side CB, but we're going to get tired of writing all those letters. Side little c is across from angle C. Side little b is across from angle B. And we're going to use that information to make this formula true, or vice versa. This formula is true whenever we have that information. The sine of angle A, divide by the side across from it, gives you a number. Sine of angle B, divide by the side that's across from it, gives you a number. Sine of angle C, divide by the side that's across from it, gives you a number. And you get the same number each time. And that little trick can let us solve some triangles. In particular, it'll let us solve angle-angle-side triangles, where we know the angle-angle-side information. It'll let us solve angle-side-angle triangles, where we know the angle-side-angle information. So you might have to go back and look at your geometry to remember what that information is. And it'll also let us solve side-side-angle triangles sometimes. Now, I'm going to be careful about the sometimes. It will work only if the information that we have, the angle that we know, is an obtuse angle or a right angle. So law of sines is for angle-angle-side, angle-side-angle, or side-side-angle if, with the side-side-angle case, if we know that the angle is obtuse or a right angle. Now what about law of cosines? The law of cosines, I like to think of it as being the rest of the Pythagorean theorem. Because the Pythagorean theorem said c squared equals a squared plus b squared, and then it stopped. But the Pythagorean theorem was only for right triangles. If we add just this little bit more on, minus 2 times a times b times the cosine of angle C, then we get a formula that works for any triangle. And by the way, once we add that little bit on, we don't have to just look at c squared. We can go from any side. So I could say b squared is equal to a squared plus c squared minus 2 times a times c cosine b. Or a squared is b squared plus c squared minus 2 times b times c times cosine a. Now you don't have to memorize these formulas. Those are on your green formula chart that you're going to have during the test, but you got to know how to use them. Last thing we want to talk about is how do you find the area of a triangle when that triangle is not a right triangle? Well, we've got two formulas that we can use for that. One of them is based on sines. The area of a triangle is 1/2 times one of the sides times another one of the sides times the sine of the angle in between the two sides. That's one way. The other way we can go is we can use what's called Heron's formula, or Hero's formula. I kind of like Hero because he's a math hero. You take S is a letter we're going to define as half the perimeter. S is going to be half the perimeter. So add up the sides, divide by 2, we're going to call that S. Now then, to find the area of the triangle, you take that number S. You multiply it by S minus the length of side A. Multiply that by S minus the length of side B. Multiply that times S minus the length of side C. And take the square root of the whole mess, and that'll also give you the area. Now in the next video, you're going to look at how to apply these rules to solving triangles. We're going to do one